This is the bending iron I constructed several years ago that I've used for bending the sides of my ukuleles and also for bending the trim strips and the binding. And it's been pretty satisfactory, but it has a couple shortcomings. The interior of this guy, and there you see when the light bulb comes on, it gets nice and bright in there. And I can dim the bulb, so I'll dim it a little bit so we can. So there you can see down there the light bulb, and it heats it up. It takes about 5 minutes or so for it to get hot. But once it get it hot, I crank this thing up to the max setting, and that heats the walls of the tube up. And then once it's hot, I dial it down to where it says low, and that tends to hold the heat. But sometimes the low temperature when you're bending something big like a ukulele side will quench the tube a little bit, and so you're constantly adjusting to how much heat you're putting into it. So crank the heat up, turn the heat down. And so you're constantly fiddling with this thing, trying to get the temperature right, and it's never quite the temperature you want it to be. So I read the temperature with I've got a readout that tells me how hot it is. It's a thermocouple that attaches to the side of this thing, and that works okay. But I'd really like to have this hooked to a controller so I can set a temperature, and the bending iron will come up to the temperature and stay there, and that would, regardless of whether you're bending a thin strip of binding or a thick ukulele side, it'll keep it hot. So that's the goal, is to modify this thing so it will do that. As a safety, I have a timer that automatically, as it'll turn it off after about a half an hour has passed. So that's a safety. So from the electricity comes in, goes through the timer to automatically shut it off if it has been on longer than a half an hour, and I can turn it to reset it to restart the timer. And then it goes through the dimmer switch, which can raise and lower the power. And then it goes to the light bulb, which heats up the tube. And then when it gets up to temperature, which I monitor with my display, I can start bending. And I can make all that work, but it's a little bit tricky. It hasn't been a big problem, but I would think I'd have much improvement if it was a regulated heater. So this is a schematic of how the heater was wired back several years ago. So the power comes in, goes to the timer, so the timer, after it times out, will shut off power to everything downstream, so it can completely turn things off. So to make it work, you have to set the timer so that it's clicking and timing down. And then from the timer you go to the dimmer, and then from the dimmer you go to the heater, the bending iron, which is basically just a light bulb in a tube to make the thing go. And then there was a thermocouple that was hooked up to a multimeter that there's the multimeter right there that displayed the temperature. So for you to do any bending, you had to click the time. Wind the timer, make sure the dimmer switch was turned on, because it's just a standard light dimmer switch. And then you had to turn on the meter so you could read the temperature. And then you'd turn everything to go. You'd set this to max as you were heating up, so the dimmer would be on full bright so that the thing would heat up at a good rate. Then once it was hot, you had to dial back the temperature, and then you had to watch the display and adjust the dimmer switch to try to regulate this manually. So every once in a while it would kind of get out of control a little bit and get too hot or too cold, and it required some attention, although it was not impossible to do. what I'm going to have after I do all this wiring change is that power will still come into the timer, so the timer will completely shut things off after it times out. So you still have to set the timer. And then I plan to keep the dimmer switch in initially, and from the dimmer switch, power then to the heater will go through the control relay, which I'll be installing, and then to the light bulb inside the heater, and that should work similarly. I'll probably run the dimmer all the way up, and if I discover that I never have to turn the dimmer back down because the control relay controls things well enough, then I'll just leave that alone. And then power from the timer will also go to the control unit, this guy right here, and that'll energize it, and then it will have the thermocouple feeding back into it, and it has a logic output which goes to the control relay. So it'll turn the power to the heater on and off at the control relay, so that it'll display the temperature that is measured by the thermocouple, and it'll have a set point that it's trying to hold. So you can watch that, how well it does holding the set point, and if it does well enough, then we won't really need the dimmer, and I'll probably take the dimmer out of the circuit. But I plan to put it in for now. Okay, I've wired in the new controller. I haven't repackaged the electronics yet. That'll come next. But I have it set for 189, and it's slowly heating it up to that. It's done it at a nice pace. I can see right now I'm not going to need the dimmer switch anymore, so that's kind of cool. And it's got it close to temperature, and it's backed off on the duty cycle. When the heater kicks on, you can see this little red light comes on, and you can also see the light bulb comes on because you can see it shining out the end. I pulled the cap off. I just stuck the new thermocouple into the end of the thing for now to see if it would control. And as you can see, it's coming up. It looks like it's going to control, so that's good. I've got the dimmer switch set on max right now. And the temperature's coming up. Looks good. And for comparison, the old thermocouple reads 223, but the new thermocouple is just resting in there, so the mechanical contact is not great. So if I take this and I press it against there, you can see the temperature rising up. And now that the temperature is above the set point, the controller says, hey, I don't need much juice to keep that thing hot because I'm about right there. And so it's backing off on how much the thing's turned on. So it looks like that'll work real well. I will leave the old thermocouple on there till I figure out what the offset should be to give me equivalent temperatures to what I was using successfully when I bent before. But it looks like this is going to control just fine. While I had everything apart, I also worked on the timer, because the timer was not ticking reliably, and that's a safety thing. I just turned it off. Now everything's turned off. You can see when I turn it off with the timer, the power to the control module goes off, the power to the relay goes off. Okay, so now I have incorporated the little proportional controller into the control loop for my heating iron, and I've tested it out. It works pretty well. I compared the temperature that I get on the old, we're using the old thermocouple to double check and make sure that the new guy works okay. The thermocouple for the controller is built into this, and it contacts the aluminum bending iron down in the base. And that results in about a 10 degree or so offset, so I'll set a little bit lower temperature than I used to set, try to control with the dimmer switch. It turns out I don't need the dimmer switch. I tried it with and without it, and it works just fine without it, so I simplified the picture by getting rid of the dimmer switch. And now I have to make a little enclosure to hold the controller and the control relay. The control relay does not run hot at all, so I don't really think I need the heat sink that's recommended, but I guess I'll incorporate some kind of heat sink in there. But all in all, this is going very well. So the next step is to build a faceplate to mount the temperature control and the control relay, so it's a little bit less unsightly. Okay, the makeover of the bending iron is complete. It has this temperature controller wired into it now, and that can be used to set the temperature that the thing heats up to. There's a little bit of offset between the temperature that's displayed here and the temperature that's I measure in the sensing point I used before when I was manually regulating the dimmer switch to control the temperature. And so since there's a little bit of offset, I'll be setting this a little colder. Usually I like to bend about 330 with the old sensing location. With the new sensing location, I'll set it to 280 and then gradually creep up from there. There's a bit of a lag in the sense temperature and the measured temperature at the surface thermocouple that was used before. So I'll start off, when I heat it up, I'll set it at 250. That'll bring it up to about 300 degrees, and then I'll creep up from 250 setting to 300 setting, and that should warm it up to the 230 or so that I like to bend at. It's really nice. It controls, so when I'm bending a big wet, moistened side, which has a lot of surface area and a lot of heat capacity and sucks the energy out of the bending iron, this will sense the dip in temperature and it'll recover it. So that's a really nice feature. Much nicer than having to constantly adjust the dimmer to try to control temperature. So I'm real pleased with it. The controller I used I got on Amazon for about $35 total with tax. And the instructions that come with that are not very good. But there are YouTube videos out there that can show you most of what you need. There's a wiring schematic of how I actually hook the thing up. It's right here. Hopefully you can see that in focus well enough. So it's like I say, it's working really well. I'm pleased. And next time I bend something, which will be for serial number 14, will be the binding. So when I bend the binding, I'll be using this, and we'll see how it goes and get the final critique, but I'm quite pleased with it overall.